Okay, in chapter exercise 6, there we go. So let's start. Question number 1. Distance between two lines represented by this line pair. So yeah, the whole thing, how to solve this question is just factorize the first three terms. So this will be x minus 2y into x minus 2y. And then add some constants. So x minus 2y plus a into x minus 2y plus b, for example. All right. And yeah, and that would be this thing, x squared minus 4xy plus 4y squared plus x minus 2y minus this. And this works because these three terms are second degree terms. So the only way to get second degree terms is by x minus 2y times x minus 2y, that expansion. And all the linear terms will be from a times x minus 2y plus b times x minus 2y. And as we can see, in this case, a plus b is 1. So a plus b is 1. And the constant term is a times b. So a times b is negative 6. This works. So now we know what these lines are. It's just x minus 2y plus 3 equal to 0 and x minus 2y minus 2 equal to 0. Cool. And now what? We want the distance between these two lines. Right, and that would be 5 upon square root of 1 plus 2 squares, like 5, which is square root of 5. And that's the answer. Question number 2. The equation of the pair of bisectors of the angle between two straight lines is this thing. If the equation of one line is given by this, then the equation of the other line is so pair of bisectors of the angle between two straight lines. So this is the pair of bisectors. So, okay, let's see what these bisectors are in fact. So 12 times 12, 3 squared times 4 squared. So 9 and 16, of course that contributes to 7. Minus this. And this would be 4x times. And in fact, I've tried this exercise multiple times. Yeah, and this is actually much harder than what I expected. It has 20 questions, but all of those questions are actually so much harder what I was expected because we didn't know some methods. Some of these methods were not given in this booklet. And the method that I'm talking about is the one that I made a video on. It's called homogenization or something, I think. So it's a way to find the angle. Okay, I'll talk about that later. Okay, let's just talk about it. It's the angle subtended by some chord of some conic, some random conic. The chord's equation must be given, and then you can find the angle subtended on any random point. So without knowing how to actually homogenize things, it is quite difficult to solve this because you can't use your conventional methods effectively. And from where did I learn how to homogenize things? It's from multiple websites, right? I know those websites which yeah, you know what websites I'm talking about. Those really are kind of stupid at times, but well, they are the only ones that actually have solutions, so I had to go there. It's a little shameful to say that because I usually try to avoid that, but I did it, and now I know a method. I mean, the method was not given there, but they were using that method, and I just got curious that what the hell is this? Like, why are you doing these random things that doesn't like make any sense? Why would you want to do this? And then I sat for like 3 hours trying to understand what was happening, and then it just clicked. Yeah, you are homogenizing this because then you will be able to factorize. So you want to be able to factorize, then it's a good way to do that. So y is negative 4/3 x, and it's also 3/4 of x. Okay, cool. So now you know these two angle bisectors, and one of these is also 1 upon. I'll just try to graph this. 3/4 x would be something like this, negative 4/3 would be like this, 1/2 would be slightly bigger. No, no, it's smaller, slightly smaller than this. And this is the actual line, this is the angle bisector. That means the other line will be like this. And yes, this matches up with this as well, I think. Right, this is the actual line. This is the angle. This is the angle bisector. Oh, yeah, I mean, it does match up. If this is the angle bisector of the other angle between these two lines, yes, that actually works, because look at that. It works. Okay, so we just need to find the slope of this guy. Call this complete angle is beta, this angle is alpha. Then this angle will be alpha plus beta upon 2 because angle bisector. So that means tan beta. We don't know what that is. Tan alpha, we do know that's just 1/2. And tan of alpha plus beta upon 2. That thing is 3/4. Alright. And from this you can figure out what tan of alpha plus beta is, and from this you can also figure out what tan of alpha plus beta is. And then we just equate these two. So the tan of alpha plus beta from this value, that will be 2 into 3/4 upon 1 minus 9 upon 16, and this is equal to alpha tan of alpha plus beta from this value, which would be half plus m upon 1 minus half m. And that means what is like 4 times 3 times 3 is 24, 24 upon 7 equal to 1 plus 2m upon 2 minus m. 48 minus 24m equal to 7 plus 14m. 41 equal to 38m. M is 41 upon 38. And there we go. So the line that we are trying to find is y equal to 41 upon 38x. And when I said that I tried this multiple times, I never actually checked the answer. It was just me trying to figure out how to solve it. Right, so a rough sketch of the method. That's what I was trying to do. So I still don't know if these are correct or not. And probably one of these will be, at least one of these will be incorrect. Next, the straight line x plus by equal to 1. So this is the kind of format that we use to normalize stuff. So this straight line makes with this curve a chord which subtends a right angle at the origin. So look, a random conic, a line, a chord subtending a right angle at some angle at some point, in this case the origin, right? So how do we do this? Just normalize it and then you will be able to solve it, right? Okay, so this conic is like some kind of hyperbola. I'm just gonna draw this real fast, like two asymptotes like this, maybe. Okay, not like this, maybe these are the two asymptotes, and then this would be the this is still bad. Yeah, this looks better. So just two random lines, you got this hyperbola, right? Yes, because look at this, it's just centered around 0, 0. This hyperbola centered around 0, 0. And a chord of this, I don't know, something like this. And it subtends right angles at the origin, right? You know the equation of this chord, it's just ax plus by equal to 1. So these 2 points, they satisfy the equation of this chord as well as the equation of this conic. So any combination of those two would also work. So this thing px squared plus 2a xy plus qy squared equal to r times ax plus by squared which is just a squared x squared plus 2ab xy plus b squared y squared, right? This equation will also be satisfied by both of these points, right? And look at this equation is representing a pair of straight lines centered around 0 comma 0, right? Yes. And it's pretty clear that these are on two different lines, right, from the diagram. And that means that, yeah, we just need to find what the slopes are, right? So what's this? P minus r a squared times x squared plus 2a minus r, okay, 2rab, that times xy plus q minus rb squared times y squared equal to 0. So this is a pair of straight lines, right? We know that this line says like y equal to m1x and this thing is y equal to m2x. Then if I divide everything by this thing t minus, okay, I should go the opposite way. Divide everything by q minus rb squared and this 2s q minus, right, this 2 divided by q minus rb squared. Then this equation, which has 1 as the quotient of y squared, this is the same thing as y minus m1x times y minus m2x equal to 0. Cool. And look at that, m1x times m2x, that would be the x squared term, but m1 times m2 is -1. So this quantity must be -1. And there we go. You got how to solve this. And this being equal to -1, that means p plus q equal to r times of a squared plus b squared. Cool. So that's one condition. There might be more conditions, but this is the one that is the most easy to find. Next, question number 4. If this equation represents a pair of lines, then the value of k is. Alright, so this is that classic kind of question where they ask a condition for the coefficient such that this would be a pair of straight lines. So the thing is, you can write this as a quadratic in x plus, okay, xy, so x times ky minus 1 and then minus of 3y squared plus 4y plus 1, right? And what would be its discriminant? Well, okay, you know how to solve this. So it's like minus of ky minus 1 upon 2 plus minus, right, minus b upon 2 plus minus square root of b squared. So ky minus 1 squared. Hey, is that? Yes, that's correct. Yes. Okay, ky minus 1 squared minus 4ac, so plus 8 times all of this thing upon, no, it should be 4, what that was, minus b upon 2a, so this would be 4, and this would be this one minus 4ac, yeah, it's also 4a, so it's gonna be, sorry, not 4a, it's 2a, right? So it's, this is also 4. Okay, so x is this thing in terms of y, but because it represents a pair of straight lines, this thing is already linear. This thing should also be a linear function of y. What that means is that this complete thing must be some kind of square, right? Some kind of perfect square in y, but it being a perfect square, that just means that discriminant, okay, let's just actually write it a little differently. So it's going to be 24 plus k squared times y squared plus 32 minus 2k times y. This is 1, this is 8, this one is like 9. Right, square root of this thing. This thing is a linear thing. That means this thing should be a perfect square. But what that means is that this guy's discriminant is 0. So 32 minus 2k squared minus 4 times 9 times 24 plus k squared. This thing is 0. So cancel some stuff out. 16 minus k squared minus 9 times 24 plus k squared equal to 0. So the k squared minus 32k plus 256 minus 9 times k squared, and then minus 9 times 24, which is minus 18 and 36 16. So minus 8k squared minus 32k plus 40 equal to 0. And that means k squared divided by minus 8. So the k squared plus 4k minus 5 equal to 0. And that means k plus 5 into k minus 1 equal to 0. So k is minus 5 or 1. Let's try it better. Cool. Got it. Next question. Question number 5. Chords of these curves subtend the right angle at origin. Once again, the same thing. Chords subtending at angle at some point pass through a fixed point whose coordinates are. So we don't know what the chord is. Right, you don't know the equation, but you want to find a point that it always passes through. So just assume the chord is like ax plus by equal to 1, because this is the easiest way to to homogenize everything, right? Because this 1 can be put everywhere. Yeah, you could also do it like assume that point is h comma k and then do everything, but then you don't know what the slope is and stuff. So it's just better to assume it's like this. Okay. And then we want to homogenize this thing. So 4x squared plus y squared plus 4y minus x times this thing. So minus x minus bx squared minus bxy. And then plus 4y, right? So plus 4a xy. Okay, wait, no, it's minus 4y, so it should be minus as well. Minus 4by squared equal to 0. Okay, and this would be 4 minus a times x squared minus 4a plus b xy plus 1 minus 4b squared times y squared equal to 0. And this thing is the pair of straight lines that we wanted, which contain the intersection points. Okay, and of course it must be like, if you want to draw this thing, it's going to be some kind of ellipse, I think. So 0 comma 0, this guy has its center at 1 by 8 comma negative 2. So 1 by 8 comma negative 2. Wait, is that for real? Yeah, it is, in fact. Somewhere like this. That's the center of this ellipse, and then it lies on that and something like this. Right. So that's what the ellipse would look like. Just have some chord passing through it. And of course, then it should not be like collinear points, because if it was collinear with this, then it would be like this would be the other point. So one of them would be 0 comma 0. And we want for a general case, it could be any chord subtending a right angle, right? I mean, it's subtending a right angle origin. That means it must be like one of the points cannot be the origin. This thing is just stupid, right? So yeah, that's how it should be. That means these lie on two different lines, and those two lines are represented by this equation. Right, so y equal to m1x m2x. Okay, cool. So what is m1 m2? That thing is just 4 minus a upon 1 minus 4b squared, and m1 plus m2 is, we don't even need what m1 plus m2 is. Why even bother to do that? And this thing should be negative 1, right? Yeah, and that means 4 minus a equal to negative 1 plus 4b squared. Hey, that's weird, because b squared, that's not supposed to, oh, this is not b squared, this is just b. Yeah, that's what I was wondering. From where did we get this weird term? It's just b over there. Yes, so this is not b squared, just that. So that's cool. And now coming back to this thing, maybe we can arrange it like that. This would be 3 equal to a plus 4b. So 1/3 times A plus 4/3 times B is 1, I think. Huh. All right. That is nice. Did I make some kind of mistake somewhere? No, it doesn't look like that. Yeah, this is definitely correct. Sure of it. And that means for any random value of A and B, you will always have this equation being true. And that means 1/3 comma 4/3 always passes through this line, which is also a chord. So it always passes through this chord, which is up and again 90 degree at the center. Sorry, at the origin. That's it. You got it. Okay, next question. Question number 6. Yeah, question number 6. If the straight lines joining the origin and the point of intersection of this curve are equally inclined to the coordinate distance, that means M equally inclined. So are the slopes like same? Wait, a random curve, straight lines joining the origin and the point of intersection of this curve and this curve. So this thing is our chord now, x plus k y equal to 1. Okay. And okay, the point of intersection of this line with this, okay, that would constitute a chord. The straight lines joining those points with the origin, those are equally inclined to the coordinate axis. So their mod m must be equal, right? Because it cannot be that they are the same slopes. That would be ridiculous because, yeah, how does that even make sense? Two different points, same slope, but also on two different lines which are not the same line. Doesn't make sense, right? That means the slopes are negative of each other. Okay, so now you know that m1 plus m2 equal to 0. Oh hell, that's really nice because we know how to get m1 plus m2 now. So just normalize and get the xy coefficient upon the y coefficient. Sorry, y squared coefficient. That would be m1 plus m2. Actually negative of that, but you get it. So we want to normalize this. 5x squared plus 12xy minus 6y squared. Just 4x minus 2y. So for that we'll put k plus xy in it. And yeah, sorry, x plus ky. So 4x into x plus ky minus 2y into x plus ky, right? Yes, plus 3. So for 3 we'll just put x plus ky squared equal to 0. If I take x plus ky common from each of these, we'll just get another line, right? Yeah, right. Yeah, whatever, just deal with it. So what is this thing going to be? It's going to be 4x squared plus 4kxy. This thing will be negative 2 ky squared. Okay, this is bad. Negative 2xy. This thing will be 3 times of x squared plus 3 times of k squared y squared and 6 times of kxy. All right, cool. Let's simplify this. So for x squared terms, this will be 9 plus 3, which is 12. For y squared terms, where did it go? This thing is a y squared term. This thing is a y squared term. 3k squared y squared minus 2ky squared. That is different. Fine. So plus 3k squared minus 2k minus 6 times y squared. And for xy terms, so 2 plus 4 is 6, but then plus 6 is 12. Oh, that's the k over there. Sorry. So 2 minus 2, this cancels. 6k plus 4k, that is 10k. So it's plus 10k xy. And now we know that m1 plus m2 is just 10k upon 3k squared minus 2k minus 6. Granted, this is not 0. If this was 0, then it would be very weird. Yeah, that wouldn't make sense. So the thing is that this must be 0. So then k equal to 0. Putting k equal to 0, this is just negative 6 and stuff. So it works. It definitely works. So there you go. K equal to 0 will work. And yeah, so that means x equal to 1. Let's see what that actually gives us. What would happen if I set x equal to 1? That would be 5 plus 12y. Hey, that's 12 over there. What is this? Wait. Oh no, this is supposed to be 12. This is supposed to be 12. Oh, that's bad. Yeah, now this is correct. Okay. Then this is not 10kxy instead. Instead it is 10 plus 10k. So plus 10 times of 1 plus k xy. So now what we want is instead that k should be negative 1. Okay, cool. So putting k equal to, okay, now I'm not going to try to justify this because this is going to get complicated. So yeah, k equal to negative 1. This works, I think. Question number 7. The angle between the straight lines joining the origin to the point common to this and that. So once again, just accord a random conic and the angle between the straight lines joining those intersection points to the origin, right? This is the classic thing. So just normalize, keep on normalizing. Oh, there's no xy term. That's really, there is the xy term. xy. And then 2x minus 4y times this line. Oh, this line can be written as 3x upon 2 minus something like that. Or you could write like this, that, wait, sorry. So 2x, I will write it as x times 2, but 2 is just 3x minus y. Alright, to normalize it, I will use this. No, to homogenize it. I'm saying normalize it. Just stick with one term. Okay, and then minus 2y times 2, which is also 3x minus y, minus 8. So it's minus 2 times of 4, and 4 is what? 3x minus y squared. For those 2 points, those 2 intersection points, this is equal to 0. Okay, so let's calculate. This thing will be 3x squared minus xy. This thing will be negative 6xy plus 2y squared, and this will be, well, negative 18x squared, negative 2y squared plus 12. No, yes, that's correct. 12xy. So look at this, 3x squared, negative 18x squared. Yes, that's negative 18x squared. What else could it be? Okay, negative 18x squared and 7x squared. That's negative 11x squared plus 3x squared, which is negative 8x squared. Look at the xy terms. Minus 1, minus 4 is minus 5. And minus 5 plus 12, that is plus 7. For y squared terms, 8y squared plus 2y squared is 10y squared, but then minus 2y squared is just once again 8y squared. So plus 8y squared is 0. Hopefully. So yeah, this thing is, and what do you want? You just want the slope, right? So y squared plus 7 upon 8 xy minus x squared equal to 0. And look at that, m1 times m2 is negative 1, so the angle is just 90 degree. Right, so it's just 90 degree. Or the more mathy version is just pi upon 2. Next question. Where did we go? Okay, question number 7. No, question number 7 we just did. Question number 8. The straight lines joining the origin to the point of intersection of these two curves. So now these are two. Oh, this is weird, will be at right angles to one another. Okay, so you just want to normalize this thing as, oh, that's actually normalizable, sorry, homogenizable, because you can cancel these linear terms by subtracting stuff. So like g2 times the first equation and then g1 times the second equation and subtract these two. And this would be g2a1 minus g1a2 times x squared. For xy, it will be, well, it's 2h, right? So 2 times of g2h1 minus g1h2 xy. I think that's, yeah, that's how it should be. Okay, and then for y squared as well, it's like just, it's gonna be b2 now. So g2b1 minus g1b2. Okay, so this complete thing is a 0 for those 2 points, which in like the intersection points of these two, for those two. So if the pair of straight lines, wait, what? No, the 8th question, sorry. The straight lines joining the origin to the point of intersection of these two curves will be at right angles when these two are negative of each other. That means g2 times a1 plus b1 equal to g1 times a2 plus b1 b2. Okay, fine, and we can write it more beautiful like this thing, because now every one term in one side and then every 2 term in second side. So this would be our condition, I think. Okay, cool. Next question number 9. If the pair of straight, what is happening? If the pair of straight, this is not supposed to be happening. Okay, question number 9. If the pair of straight lines, this and that, so all perpendicular, such that each pair bisects the angle between the other pair. Oh, okay, fine. So both of these pair of straight lines are having 90 degrees angle. So maybe this is the first pair of straight line, and then you want the other pair of straight line to be bisecting the angles. So it will naturally be at 90 degree. And that means this is 45 degree everywhere. Okay, I understand what's happening. So maybe just say that the first pair was like this. In fact, just write it a little differently. I'm going to write it like y squared plus 2p xy minus x squared equal to 0, and y squared plus 2qxy minus x squared equal to 0. So the first guy, I'm going to write it like this: y minus m1 x times y minus m2x. So now we know that m1 plus m2 is just negative 2p. Second guy, I'm gonna write it like, in fact, and yeah, m1 times m2 is just negative 1. So y minus capital m1x and then y minus capital m2x. And then the angle between two of them, the acute angle between two of them, that is 45 degree, right? So you would have m1 minus m1 upon 1 plus m1 m1. The mod of this thing is just 1. Yeah, that makes sense. Okay, and similar thing for m2 and for m1 and m2 as well. Okay, so this guy and that guy also the same thing. Oh, this is bad. So it's more like you just rotated this by 45 degree, you rotated this guy by 45 degree. So you could always just apply a rotation matrix, right? Okay. So it's like if you were to rotate the rotated version back, by the opposite angle, then it would become the original version, right? Okay, I understand this. But I want to do it more algebraically. What do you want? Bisects the angle between each other, then some kind of relation between these. Okay, so you have this kind of thing. So mod of m1 minus m1 equal to 1 plus m1. M1 like this. Same thing can be said for m2 as well. So m2 minus m1 equal to 1 plus m2 m1. Oh, okay. But then m2 is just negative 1 upon m1. So this would be 1 minus, oh, this is very nice. Right, because, wait, no, it's not negative 1, so like 1 plus m1 m2. Okay, then, okay. Equal to, oh yeah, this is obvious. This is obvious. If this happens, then that happens as well. Right, cool. But you really do need m1 plus m2 somehow to actually get anything done. I mean, it's just 2 times of that equation, so it shouldn't be that problematic, right? How problematic could it even be? Ah, come on, think. I really just want to apply a rotation matrix and get it through it. Well, whatever. Just do it. Just do it now. So, say you have an x comma y point, which is satisfying this pair of straight lines. Just like it has been satisfying this equation x y squared plus 2qxy minus x squared equal to 0. So this satisfies this equation. And then you want to convert this into this guy, so that now this x comma y, or this capital X comma capital Y, all right, and this guy satisfies this equation, capital Y squared plus 2q capital X capital Y minus capital X squared is 0. And what is capital X capital Y in terms of small x small y? Capital X capital Y is just small x small y, but with some rotational matrix applied. In this case, this angle is 45 degrees. So you want to rotate by 45 degree. This thing is cosine, and then negative sign over here. And wait, really? What happens to your I hat thing? It just gets converted to, I mean, with respect to this guy, it okay, it becomes this thing. So it's like, oh, this is different. It's very, very different now. It's like you're shifting everything. But you know, in the end, it's just that, like, the order doesn't matter. The angle being clockwise or anti-clockwise doesn't matter, because it's so much, like, it's just symmetric everywhere. So cosine minus, and even if you apply the inverse matrix, it would still be working. Sine and cosine. I think this is the matrix to rotate a point clockwise, sorry, anti-clockwise, right? So if you rotate this thing anti-clockwise and get this over here, it will not satisfy this equation. So that means capital X comma capital Y, this thing is okay. So we cosine x plus sine y, and then minus sine x plus cosine y, and you're just gonna put this into this guy and see what we get, right? Yeah. So putting capital Y as that, just have sine squared x squared plus cosine squared y squared minus 2 sine cosine xy, and for x squared this would be negative cosine squared x squared. Well, this is weird, but that's how it is. Plus, and then this would be something times x y z. It's a lot of math. Oh, why am I doing this? You already know the values. Why do you even do this? So yeah, it's gonna be 1 upon square root 2 times 1 minus 1 1 1 xy. And what I'm going to do is that instead of just rotating, we will also extend this a little bit. So now this will be x comma y. So I will make this square root 2 times this vector, so to erase this thing. So you have capital X, capital X, capital Y. Capital X, capital Y, we can write this thing in that case as small x plus small y and then minus small x plus small y. And this would still satisfy this, this line. So this pair of straight lines basically. Cool. Got it. Okay, so just put it like that and we'll see what equation we come out with. Right, and this thing works for all values of small x, small y, right? So for all values of small x, small y, if this is working, then the equation that we come out with is the same thing as this equation in that case. So x plus y squared minus x minus y squared. Yeah, that's like 4xy. Then plus 2q times xy, which would be x squared minus y squared. So this would be x squared plus 2 upon q xy minus y squared equal to 0. Or in other words, y squared minus 2 upon qxy plus x squared equal to 0. And wait, what? Battery down. Just wait. Okay, now we're ready to go. So, wait, why did I write the same equation 2 times? One of them must be p, so this is p probably, I don't know. So, yeah, that just means like 2p is, and this should be negative. Sorry, this is actually positive over there. No, wait a minute, this y means, yeah, so it should be negative over there. And that means 2p is just negative 2 upon q. So p cube is negative 1. Got it. Which isn't that far-fetched, right? Yeah. Cool. P cube is negative 1. I think so. So this is our answer. Next question. Question number 10. A pair of perpendicular straight lines drawn through the origin, forming with this line an isosceles right triangle okay, at the origin. Right angle at the origin. Okay. Isosceles right angle. I have seen this kind of question once, I think. The equation to the pair of lines is so yeah, you just need to figure out what this distance is and stuff. And wait a second, should just try to graph this first of all. So what line is given to us? 2x plus 3y equal to 6. So the x-intercept is 3 and the y-intercept is 2. This would be our line, something like this. Okay, and you just have, this is like the slope. What is this slope? This guy has the slope negative 2/3. So this should have the slope 3 upon 2, right? And then you just have two other lines forming 90 degrees with each other, having this as its angle bisector basically. So what we are saying is like m1 plus m2 upon 1 minus m1 m2, that would be tan of alpha plus beta, which is also, well, this thing is tan of alpha plus beta upon 2. So it's like 2 times of 3 upon 2 upon 1 minus 9 upon 4. This would also be tan of alpha plus beta. And you also know that m1 times m2 is negative 1. So this thing is just 2. Now that's nice. Multiply by 4 and this would be, this cancels anyway. So this thing is just 12 upon negative 5. And that means m1 plus m2. Okay, I hope this is going correctly. m1 plus m2 is negative 24 upon 5. And m1 times m2 is negative 1. Okay. Hmm. Oh, we know how to do this thing. So instead of writing it like that, instead of writing it like that, I will write it like this: 5m1 times 5m2 negative 25, and 5m1 plus 5m2 equal to negative 24. So now I can guess, and my guess is that one of them is negative 25, other one is 1. So you could have m1 being negative 25, negative 24 upon 5, and the other one m2 being 1 upon 5, and then this would work, right? Yeah. Uh, no. Something's not correct about this thing. Because m1 times m2 should be negative 1. Okay, that's negative 25. How can it be negative 24? It should be negative 25 over here. That makes sense. So one of them is negative 5, the other one is 1 upon 5. So if I add these up, it would be negative 24 upon 5, which is working correctly. So there we go. And these are of course perpendicular to each other. So the equation is a pair of straight lines. The first line is just y equal to negative 5x, and the other one is y equal to 1/5 x. And now we know how to do this thing. So y plus 5x times 5y minus x equal to 0. Cool. 5y squared minus 5x squared, and then minus xy plus 25xy, so plus 24xy equal to 0. There we go. You got the equation. Okay, next question. Question number 11. What does it say? Let PQR be right angle isosceles triangle, right angle at P something. If the equation of the line QR is given and the equation representing a pair of once again, that's a very kind of question. So, pair of straight lines, right angle at that point. Come on, think of it. What I'm thinking is like use this equation to maybe build a pair of straight line equation, which would obviously be only true for any point on this line. And then if that, okay, that can't be because not every line is on that. So, no, that won't work. So do we just have to go by the actual, I don't know, calculative method? Maybe. So let's try it out. Which is this? Okay, fine. So question number 11, right? If the equation of the line right angle isosceles triangle, that just means it's 45 degree and stuff. All right. So centered around 2, 1. So I'm gonna move everything to 2, 1 as well. So about P, you have this point of view that 2 times of, so the thing that we have been describing as x for now, this was actually just x plus 2, and then y plus 1 equal to 3, right? Because in the point of view of P, your x and y are now smaller than what they were originally. So the actual x and y that we were using to describe this line, those would have to be replaced by these smaller x and y plus some stuff. That would be correct. So 2x plus y equal to 4 plus 1 is just 5. So okay, this is 2. This thing is plus 2 equal to 0. This thing is our line. All right. And now what? You can figure out what the slope is and stuff. And yeah, In that case, figure out what the other two lines should be. So this guy has slope -2. I mean, the same slope would be for this thing. Okay, I get it. But we will be using this to find those lines. So this guy has slope -2. So tan of alpha plus beta is -2. Sorry, alpha plus beta upon 2 is -2. So tan of alpha plus beta, that would be 2 times of -2 upon 1 minus -2 squared, which is -4 upon -3, I think, which is 4/3. Alright, so 4/3 is also m1 plus m2 upon 1 minus m1 m2, but then m1 m2 is -1, so this is just 2. So m1 plus m2 is 8 upon 3. Okay, and of course m1 m2 is -1. So what works like that? Oh yeah, we know something. It's like 9 upon 3 and 1 upon 3. So 3 and -1 upon 3. Yes. So m1 equal to 3, m2 equal to -1 upon 3. Just like the previous one, I just guessed some stuff. So we got it. We got the lines. This would be y equal to 3x at 3y equal to negative, or like 3y plus x equal to 0. But now we want to convert this thing into the point of view of P. So about P, these are the two lines that we actually want. But now we want to go back to the x that we have been using to describe it from the point of view of P. You want to change that to y minus 1 and x minus 2, right? Because these are smaller than what the actual x and y are about O. And then this would be 3 times y minus 1 plus x minus 2 equal to 0. And then this would be 3x minus 6, like, okay, 3x equal to 6 minus 5, so 5 plus y. And this would be x plus 3y equal to 2 plus 3 is 5. Got it. So y minus 3x plus 5 times x minus 5 plus y plus 3y minus 5 equal to 0. That is our pair of straight lines. Now we have to do this. So y minus 3x times x plus 3y, that will give us all these square terms, right? I mean the second degree terms. That would be 3y squared minus 3x squared, and then negative 9xy plus 9 plus xy, that would be negative 8xy. Then 5 times this thing and minus 5 times this thing. And that would be 5x plus 15y minus 5y plus 15x, which is 20x minus, sorry, plus 10y. So that is the linear terms, and the constant term is negative 25. So that is our pair of straight lines. 3y squared minus 8xy minus 3x squared plus 20x plus 10y minus 25 equal to 0, which is hopefully correct, I think. Next question. Question number 12. The pair of straight lines together with this line form a triangle, which is, okay, this is a pair of straight lines, this is together with that. So both of these lines are centered around what do you call it? Both of these lines are centered around the origin. So that's the center of the pair of straight lines. And together with this line, this is a weird thing. So this guy has -1 as its slope. X plus y plus 4. Try to graph this thing. Equal to -4 square root of 6, right? So this would be like that line. And then these two lines are just reciprocal slopes of each other, and they add up to 4. Okay. Add up to 4, huh? When have I seen something like that? Never, in fact. Anyway, these two are just lines like this. So because they are reciprocal, this has some kind of symmetry about the y equal to x. If y equal to x, this line would be the angle bisector in that case because they are like reciprocals of each other. Right? So if this thing is theta, then this thing would be theta because this completely must be 90 as theta. Right? That means this y equal to x is the angle bisector. And because this is a -1 slope, it's perpendicular to that. Well, that's nice. So this triangle is isosceles. As you can see, it's not right angled. It's just isosceles. That's all you can say. Well, what is the angle between these two lines? It could be that is 60 degree, but we'll see about that. What is this angle between these? So you just want m1 minus m2 upon 1 plus m1 m2, this value, at least the mod of that, which is square root of m1 plus m2, which is 4 squared minus 4 m1 m2. m1 m2 is just 1, so it's just 4 like that, upon 1 plus 4, sorry, 1, m1 m2 is 1. 6 minus 4 is 12, square root of 12 upon 2, which is square root of 3. So tan of this angle is square root of 3, this angle must be 60 degrees as we expected because they always put these kind of questions. So this is an equilateral triangle. That's it, we are done. So it's equilateral. That is our answer. Right, next question. Centroid of the triangle, the equation of whose sides are given. Okay. Oh, look, centered around 0, 0. Yes, that's cool. And some other random thing. Okay, the centroid of that triangle. Oh, so do you want me to find the intersection points? Well, that would be stupid, right? We definitely don't want to be doing that. Hey, you can always find out the midpoints, I think. Yeah, I mean, think about it. One of the vertices is 0, so this is some kind of triangle. This is some line which we don't care about, like, yeah, and the line running through the midpoints of these two, it just has this distance half of what it should be, so that means just have to make this 4 into 2 and you will be having this line in that case. That's actually really nice. So 2x minus 3y plus 2 equal to 0, right? Or you could say you converted you just changed x with 2x and y with 3y because the xy over here would translate to 2x and 2y over here, which satisfies this equation that 2x minus 3y plus 4 equal to 0. So 2 times of 2x minus 3 times of 2y plus 4 equal to 0, that will give us this equation. So now we know what this thing is. You know the centroid is going to lie somewhere over here, right? And you just want the midpoint of this thing, like that. Okay, so if this thing is x1, y1, and this thing is x2, y2, then what you actually want is just x1 plus x2 upon 2 and y1 plus y2. Oh, that actually is like easy to find, not that hard. So all you gotta do is just put this linear equation into the quadratic equation that you had for this thing, right? So from that you can get, or you could just find what this is. Is this like factorizable? Where is that question? 12x squared minus 20xy plus 7y squared. Is this somehow factorizable? If it is, then we are done basically. So 12 times 7, and then you want 20. So that's even. That means we are at 6 and 14. That will work. So it is in fact factorizable. And you can find out what these lines are. And then you can find out the points of intersection and everything. Oh. Or you could also do what I told you. Just to prove that what I'm telling is actually correct, I'm gonna do it. So 3y equal to 2x plus 4, isn't that right? And you just have 7y squared and stuff over there. So I'm gonna put y as 2x plus 4 upon 3 in there and see what we get. Or you could be putting 2x as something. That's like an easier thing to do, so I'm gonna do at first. 2x is 3y minus 4, isn't that right? I'm gonna put that in there. So 12x squared, that is like 3 times 4x squared, which is 3 times 2x complete squared. So 3 times of 3y minus 4 squared. Okay, minus 10 times y times 2x, and 2x is just 3y minus 4 plus 7y squared equal to 0. I'm just going to simplify this a bit. Okay, so it's like 3 into, what is this, into 9y squared minus 24 pi, right? 1 times 2 is 24 plus 16, and that would be 27y squared minus 2 times 24 is 6, and this is getting long. Okay, keep on going. 27y squared minus 6 and 12, which is 72, I think. 72y plus 16 times 3, which is 48. That's the first part. The other part is minus 10y times all that. So that would be negative 30y squared plus 10y times 4, which is 40y. And then the last part would be 7y squared. So this plus 7y squared. What would that be? So negative 30y squared plus 27y, that's just 3, so minus 3y squared, and that plus 7y squared is just 4y squared. So 4y squared minus 32y plus 48 equal to 0. And that means y squared minus 8y plus 12 equal to 0. Hey, you just got it. You got the y values. Basically, we are done. Oh yeah, that's it. And in fact, to do this thing as well, you would have to first factorize and then put, I don't know, x as in some function of y into this, or the other way around, and you would have to solve that equation, which is now a linear equation, but still that is the same kind of problematic thing. So this also works the same way. Okay, so you don't even have to factorize this, even though you can easily just have y equal to 6 and y equal to 2. But the thing that I was saying is that y1 plus y2, that will be 8, because yeah. So that means the midpoint, that is 4. The y coordinate of that midpoint is 4. What is the x coordinate? You have this equation, right? The midpoint also lies on this line, of course. And putting that in there, 4 in there, just have 2x equal to 3 times 4, which is 12. 12 minus 4 is 8. So x would be 4 as well. So yeah, 4, 4 is the centroid. There we go. Next question. Question number 14. The angle between the straight lines given by this and that. All right. So this sine squared alpha is kind of hindering everything. I'm just gonna put that in there. So like x cot alpha minus y squared equal to x squared plus y squared. Let's like simplify this. So x squared cot squared alpha minus 2xy cot alpha plus y squared equal to x squared plus y squared. Yeah. This, oh, it's plus y squared. That's already there. It's already there. It's cancels. So x squared times cot squared alpha minus 1 minus 2xy times cot alpha equal to 0. So either x equal to 0 or you have x into cot squared alpha minus 1 equal to 2 times cot alpha times y, which means y upon x is, oh yeah, this is gonna get complicated. Okay, x upon y was a better thing to use, whatever. So y upon x that thing is cot squared alpha minus 1 upon 2 cot alpha. Which should be 1 minus tan squared alpha upon, so multiplying both sides by tan squared alpha, this should be 1 minus tan squared alpha upon 2 tan alpha, which is 1 upon tan of 2 alpha, which is cot of 2 alpha. Okay, which means like y upon x is, or I can say y is tan of pi by 2 minus 2 alpha times x. So one of them has this angle, the other one has, it's just x equal to 0. That means that is just a vertical line. All right, got it. So if I were to draw this diagram, one of them is just this vertical line, the other one has this angle, pi by 2 minus 2 alpha. That means this angle is just 2 alpha. And what do you want? Number 14, angle between the straight lines. That is 2 alpha. There we go, 2 alpha is the answer. Question number 15. The length of the intercept cut off from this line between the pair of the lines is, okay, the length of the intercept cut off from this line between the pair of these lines. Never encountered that question. So pair of lines, you say. Some other kind of way to solve this, maybe, like you can always find out the distance between the origin and this guy. Oh wait, is this vector? Yeah, this is actually vector as well, I think. No, it's not. It's not. It's like a plus 1 upon a. So it's just, this is not vectorizable. It looks like that. We're still gonna try, see what we get. Because a times a is a square, which is also a square times 1. So is, yeah, I think it's less factorizable. But is this gonna give us something nice? And this would be ax times x plus ay, and this would be plus y times x plus ay. So ax plus y times x plus ay equal to 0. So one of them is just y equal to, yeah, these are the two lines. It's not that bad in that case, because look at that, it's just y equal to x minus 2 or something like that. Like, yeah, first thing is just y equal to negative ax, other is y equal to negative 1 upon a times x. Okay, and then you have the third line is y equal to x minus 2. So if I were to graph this, x minus 2, so when x is 0, y is negative 2, and this is how it should be. And then slope 1, and again, it's like these. So notice that this thing, y equal to negative x, is just perpendicular to this, and you just need to find what this length is. Yeah, and yeah, like these are just reciprocals of each other and stuff. Okay, you still have to find what this length is. That's a big problematic thing. But hey, at least you now know what the slopes are, right? So I don't know. Maybe this is like a. This has slope negative a. That would mean tan of this angle is a. Okay. So the tan of this angle, which is okay, it's the 45 minus that. No, 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 no. That's not gonna be a nice thing. You know what this is? You know what that is? This is also tan inverse of a. Both of these things are just the same thing. Okay. So now you know what these angles are, and you know what this distance is, so you can figure out what this length should be. So it's just, what is this thing? It's just pi by 2 minus 2 tan inverse of a upon 2. So it's pi by 4 minus tan inverse of a, right? Tan of that thing. Well, actually not tan of that thing. It would be, no, it is in fact tan of that thing. So tan of this thing, and that times this distance, that would give us this thing. But you obviously need 2 times of that because you want the whole length. And what is this distance? You can figure that out actually. So it's a 0, 0 is like 2 upon square root of 1 plus 1. Yeah, there we go. You got the length. This thing is square root 2. So it's 2 square root 2 times tan of pi by 4 minus all that, and which is going to be 1 minus a upon 1 plus a. Cool, you got it. That is our answer. This is a lot of stuff. So yeah, this is our answer. 2 square root 2 into a, sorry, not that, it's just 1 minus a upon 1 plus a. That is our length of this base. Which question was this? Question number 15? Question number 16 is the lines ax square plus 2hxy plus e. Okay, fine. Form two adjacent sides of parallelogram. Oh, and this line is one diagonal. Oh, it's the other diagonal. I get it. Then the equation of the other diagonal. Okay, fine. Yeah. Wow, this is weird. The equation of the other diagonal is. Okay, come on, think of it. You gotta have something to do with it, right? So you know it's gonna be like just two lines, and this line has some slope. Yeah. The other diagonal. Without using vectors, this is kind of a hard thing to do. I mean, think about it. The parallelogram can have like, it has any kind of side, like it can be as large as it wants, right? This could be like this. So this line is actually, yeah, like it could be anything. This can be anything. And okay, the other diagonal. Come on, think of it. Can't just leave it like that. So wherever this intersects with this pair of straight lines, you will find those points, and then you will take the midpoint of that thing, and that would be essential in finding out what this line is. So now I understand how to do this thing. Let's do this. Question number 16, right? Yes. Okay, cool. Let's erase that actually. This is not part of question 15. Whatever. Next. So we just want the midpoint of the chord, which is having this equation and about this conic, right? Yeah. How do you find that thing? I just want to eliminate all the stuff with y in it to get the x values. And how do you eliminate all the stuff with y in it? Just have to do it. Just have to put it like that. Oh, this is gonna be very bad. So it's gonna be 2am squared x squared plus 2h, right? Because I want my and stuff. So 2h m x times my plus b times my squared equal to 0. That's the thing. And now instead of my, we put 1 minus lx. So 2am squared x squared plus 2h mx instead of my, I'm gonna put 1 minus lx, and for b it will be, so like my squared, it's gonna be 1 minus lx squared equal to 0. Cool. Okay, time to do this thing. X squared times 2am squared. Okay, from here you get x squared terms as well, so it's going to be negative 2hml, and from here as well it's going to be plus el squared. Okay, then for x you will have 2hm times 1, and for this guy it will be minus 2bl. Yes, and then for the constant terms you only have one constant term over here, right? So just plus b equal to 0. So what do you want? Just want m1, sorry, you just want x1 plus x2. It would be this upon, oh, this is getting bad, 2hm minus 2bl upon this thing, 2am squared minus 2hml plus bl squared. Wow, that is horrible. And this thing is x1 plus x2. Yeah, and then you just have my equal to that. So sorry, what? My equal to 1 as lx, lx. My will be 1 minus l times all of this thing. This thing is x1 plus, oh yeah, actually you should take the half of that because average. So the midpoint, x midpoint, that will be hm minus bl upon 2am squared minus 2hml plus bl squared. Cool. And similarly you can find what, so all of this, you just want that. So now you got what the midpoint of x is like, and you also have my midpoint is 1 minus a, what was that once again? Minus lx, right? So lx midpoint, which is 1 minus l of all these things. So this will be 2am squared minus 2hml plus bl squared minus l times this numerator, which is hml plus bl squared. Hey, this is weird. Yeah, this is very weird. Did I just mess up something? Okay, I think I did. So now I can't go back because it will take a lot. Oh, okay, fine. So x squared plus all of that, it should be negative over here because yes, negative b upon a, and that's why it should be bl. As I thought, I did mess up this. It's only bl minus hm, and now it's correct. Okay, and now we can do this thing. My mid is just 1 minus lx, which would be 2a m squared minus 2hml minus, so l times that is going to be minus bl squared, and then plus hml upon all of that stuff once again, just 2am squared. Yes. Yeah, you get it. 2hml. So the thing is, this numerator, it just becomes 2am squared, then this cancels, okay, minus hml. So y mid is 2am minus hl upon, well, yeah, all of that stuff. Hey, why is this 2 and stuff? Okay, I made one more mistake, I think. It's getting problematic. Why is this 2am over here? Oh god. think this would have been am squared and not 2am, I think, because symmetry, yeah, right? Of course, it must be like that. So this would have been all of that. And the denominator, of course. So the slope for the midpoint, that would be am minus h. What do you actually want to find though? Number 16 is equation of the other diagonal. So it's just the slope. You just want to find the slope. So y upon x, that thing is cool. This is the thing. Yeah, there we go. This is the equation of that line. Question number 70. Yeah. Through a point A on the x-axis, a straight line is drawn parallel to y-axis so as to meet the pair of straight lines. Okay, A is on the x-axis, straight line drawn parallel to y-axis, so x equal to whatever is the x value of a pair of straight lines. Okay, so to meet the pair of straight lines in B and C, if AB equal to BC, okay, this is so, AB equal to BC, then, oh wow, some random thing, right? Okay, so we just have to look for the, I mean, if you try to graph this, it would be something like this. Just have to look at the y values, because what you're basically saying is like, this is what A, B, C, right? Because A equal to B, C. What that means is, call this thing like y naught, and okay, this is just 0. We know it's just 0. Right, so it's x naught comma 0. I'll just call this thing x naught comma y1, and this thing is x naught comma y2. So y2 is 2 times of y1. Basically, that's what they are saying by the second condition. Question number what? Question number 70. AB equal to BC, that means this thing. And yeah. Okay, this is weird. But you just have to put x naught and into this things. Like this whole thing is just x equal to x naught, this line. So putting x equal to x naught into this thing, what do you get? You get ax naught squared plus 2h x naught y plus b y squared equal to 0. So yeah, like y squared plus 2h x naught upon b is y plus ax naught squared upon b equal to 0. All right, cool. This should be y squared. Yes, and y2 is 2 times of y1. Okay, this is weird. So maybe like, I don't know, it's like 2y1 plus y1, it's like 3y1 is this. Yeah, so minus 2h x naught upon b. That is what 3y1 will be, because addition of the roots. But then 2y1 squared, that will be ax naught squared upon b. So we could just, we can do this thing in that case, and then just square this thing. So you just have ax naught squared upon 2b equal to 2h x naught upon 3b squared. And guess what? These x naught things will cancel away. So it's independent of whatever x naught is. And there you go. You got the condition. I just want to minimize this thing. How do I do it? Okay, whatever. Just minimize this. Okay, so you got it. This is your condition, and this will become a upon 2b equal to 4h squared upon 9b squared, which means 9ab squared. Okay, that b cancels. Cool. So 9ab equal to well, that 2 is still there, so it's gonna be 8 h squared. Cool. Question number 18. The equation of the pair of straight lines bisecting the angle between the lines through this and perpendicular to the line. Huh? So, okay, lines through 1, comma 2 and perpendicular to the line pair. Oh, okay. So through 1, comma 2, we will have a pair of straight lines, and both of those lines are just perpendicular to this line pair. Okay, I understand that. Both of them perpendicular. That cannot be. So it's like one of them perpendicular to one of these, and then other one perpendicular to the other one, like that. And you want the equation of the pair of straight lines bisecting the angle between those lines. Oh, I understand. At some point like this, something like, I don't know, just some random line. Could be like this. I don't care about it. So start like this. Perpendicular to it, that means only two lines like this. And then just want what? The angle bisectors of these two lines. That would be this line and this line, of course. No, wait, but these are not necessarily symmetric or all things. Okay, let's draw even more general. So it's 1, 2, some point like that. We don't know what that point is. Actually, we do know because they have given us the equation, I think. Yeah, so you can figure out what this is actually, what are these two lines and stuff. But you only care about the slopes really. So yeah. Maybe you have to, in fact, first of all, find what the actual pair of straight lines through 1, 2 is. And then find their angle bisectors. Okay. But there could be an easier way as well, right? So just some random slope, not caring much about what that slope actually is. And then it's perpendicular to this and to that. I don't want this to look perpendicular. I don't want this to look perpendicular at all. This will work. Something like this. So this is very bad looking, but this will work. Okay. So maybe like these two lines. And then what? Just want the angle bisectors of these. But these are perpendicular to this thing, right? Oh yeah. Hey, that's weird. No, you just have to do it. Just have to find the actual lines and stuff. And man, what I was thinking is that you have these two slopes. They have their angle bisectors, right? And then you would rotate it by 90 degrees. So like this line would just turn out become being this line like that. And then this angle bisector of these two lines, that would also be rotated by 90 degrees. And this is also rotated by 90 degrees. So if we go through that method, then essentially all we have to do is just find the angle bisectors of these two and then rotate them by 90 degrees. Still that complicated. Still just very complicated. Huh? Man, isn't this an easier way? What's the angle between these two lines? That won't be enough. You just have to find the lines themselves actually. Minus 36, that can be written as, I don't know, for 6 times 6 and 3 times 12, no, it won't work. 9 times 4, okay. Just find the slopes, god damn it. Okay, so 6x, right, so how you factorize it? It's like 6m squared minus 5m plus, sorry, minus 6 equal to 0. That's what this thing is, right? Like 6m squared minus 9m plus 4m minus 6 equal to 0. So 3m into 2m minus 3 plus 2 into 2m minus 3 equal to 0. So m is either 3 upon 2, is supposed to be 3 over there, 3 upon 2, or m is negative 2 upon 3. Oh, what about that, huh? These are perpendicular to each other. What? Uh, oh, this is really nice because these two are perpendicular to each other. That means, yeah, this was nice. Okay, I was not expecting. Yeah, I mean, look at these. These two are opposites of each other, so it would be expected that these are perpendicular and stuff. So you got it. It's just the angle bisectors of these two lines, and that would also be our final answers. Because these are perpendicular bisectors, even if you, I mean, okay, because these are perpendicular, even if you rotate 90 degrees, you still get the same pair of straight lines. So their angle bisectors is also the angle bisectors of the pair of straight lines through 1, comma 2. Cool. And yeah, what would be the angle bisectors though? The first one would be, let's just think about it, like 2m upon 1 minus m squared is 3 upon 2 plus minus 2 upon 3 is minus 2 upon 3 upon 1 minus all that stuff, like 1 minus, yeah, it's plus 1. That would be 9 minus 4 is 5, 5 upon 6 upon 2 is 5 upon 12. So 14m equal to 5 minus 5m squared, 5m squared plus 14m minus 5 equal to 0. So minus 25. Not sure what to do with that. 14. No, that's not good. Sorry, it should be 24. What am I doing? It should be 24. So yeah, now minus 25, that means like that. It should be, that's 12. Okay, that's 24. Yes, that's correct. What was I doing? So either m is negative 5 or 1 upon 5. There we go. We got the lines. So m being equal to 5 means negative 5 minus y minus y equal to minus 5x, and this is y equal to 1/5 of x. So y plus 5x into 5y minus x equal to 0. Right, then will be 5y squared minus 5x squared and 25xy minus xy, it's just 24xy. There we go. Or we could have got the same thing from this equation directly as well, right? But yeah, wait, it's 24. Why did I write 2? 24xy because 25xy. So that is it. That's it. It's the pair of straight lines. Question number 19. If the line y equal to mx bisects the angle between the line, okay, and m is the root of the quadratic equation. Wait, what? Oh, so you want to find a quadratic equation that m is the root of. Okay, so m1 plus m1 plus m2 upon minus m1 m2, that is 2m upon 1 minus m squared, something like that. Right, both of them work probably. Yes, alpha plus beta upon 2, well, it can have two values. I mean, it gives you generally a thing. Okay, and what is this value going to be? m1 plus m2, just know it's negative 2h upon b, right? Not upon a, because it's set to y. And 1 minus m1 m2, which is a upon b. And this would just be basically 2h upon a minus b equal to m upon 1 minus m squared. So 2h minus 2h m squared equal to 2am minus, okay, what am I doing this? 2 into a minus b times m. So h times m squared. Why didn't I cancel these two first? I don't know. H times m squared plus a minus b m minus h equal to 0. There you go. Or if you want to write more beautifully, it would be m squared plus a minus b upon h times m minus 1 equal to 0, which also signifies that these are like perpendicular to each other, because angle bisectors are generally perpendicular. Generally, I mean, they are perpendicular. It's maths, not physics. So, yeah, this is the quadratic equation. Cool. Question number 20. The image of the what does it mean? The image of the pair of lines represented by this equation is by the line mirror y equal to 0. Okay. No, this by the line thing is okay. You should remove this the line, and then it would be correct. The image of the pair of lines represented by this equation by the mirror y equal to 0. Right. Okay. No big deal. So it's just y equal to 0. Just replace y with negative y, and that would be it. So yeah, what's the big deal about it? Like every point, it just goes down or up. So its y value gets negative of what it was originally. So it's like ax squared. So if we want to remap, so you have taken the image, and now the y value that you have, negative of that y value would be the original y value. So we are going to put that thing there, ax squared. It's going to be negative 2. Hey, this was actually much easier than the other questions. So that's it. Question number 20 is done. Let's check. Question number 20, yes, this is correct. Question number 19. Of course, that is correct. So yeah, I mean, quadratic equation, that's why they used x, but you can use anything you want. Question number 18. 5y squared. Okay, what is all of this? Why all of this linear terms? I don't understand this. Oh no, you want about 1 comma 2. I didn't. Shit. Now I understand what went wrong. About 1 comma 2, these would not be the lines. This would be about 0 comma 0. So the first 3 terms, well, at least those are correct. Yeah. But you also have the linear terms because it's about 1 comma 2. That was question number 8, right? Oh, sorry, 18, right? Yes, about 1 comma 2. And that's why it went wrong. But at least it was a good try. Question number 9, 17. Yes, this is correct. Question number 16. Yes, this is correct. Question number 15. Yep. Oh, it's a minus 1. And why is that a minus 1? I mean, I did take magnitudes and stuff, but why is this a minus 1 of all things? Okay, maybe they took a as being a very big value. So like this complete thing is, this has the slope a, and then this would have slope 1 upon a. Same thing, just the same thing, except that I took a to be less than 1, and that's why 1 minus a. So you want the distance, right? So just take the magnitude of these things. So it's correct. This is correct, definitely. Question number 14. 2 alpha. There we go. Question number 13. Oh, this is different. 8 third, comma 8 third. Ow, I made some kind of mistake. I'm gonna do it once again later. Equilateral, yes, that's correct. 3x squared minus 8xy. Okay, they always use. Why don't you use y squared? Okay, so 3x squared we have minus 3x squared, 8xy we have minus 8xy, minus 3y squared we have 3y squared, then minus 20x plus 20x minus 10y plus 10y. Everything's correct. So yes, this is the same equation. Question number 11 was question 5. Question number 10. Yes. Yeah, cool. That's the same thing. Yep. Question number 8. Yeah, the same stuff. It was the same stuff, right? Question number 8. G1 times A2 plus. Yes. Okay, question number 7. I upon 2. Cool. Question number 6. It's equal to negative 1. Yeah. Question number 5. 1 by 5. Something's just wrong. I mean, why do I get these coordinates incorrectly most of the time? 1 upon 5 and negative 4 upon 5. Huh. Okay. This should be 5. Oh yeah, this should be 5. Oh, that was about it. So a plus 4b equal to 5. And then why is this negative and stuff? Because that's negative 1 plus 4b, yes. And this is 4 minus a. What else can it be? Okay, I will see what went wrong with this. It's not 4. Yeah, that's correct. Question number 3. Cool. This was not calculative, and that's why I went correctly. 41x minus 38y plus. Yes, this is the same thing. So 1/5. Yes. So the thing that went wrong was question number 5 and question number. Which question number? Question number 13. We'll try to see what went wrong with that. And question number 18, that was wrong because, yeah, 1, 2, that's what we have shut down. So question number 5 and question number 13, let's look at them once again. So for question number 5, chords of this curve with subtender right angle, the origin pass through a fixed point whose coordinates are. So once again, 4x squared plus y squared minus x times ax plus by plus 4y times ax plus by. That's just it. Okay, so 4 minus a into x squared, because yes, no other x squared term over here. Okay, plus y squared. Y squared has 1 plus 4b y squared, and then plus some xy terms which we don't really care about. So we just want this to be perpendicular, right? So what we want is 1 plus 4b plus 4 minus a to be equal to, yeah, this was minus a, and this was not 1 minus 4b, it was 1 plus 4b. Why did I choose 1 minus 4b though? Not sure. But yeah, what they are saying is actually correct, and this just means negative 1 upon 5 times a plus 4 upon 5 times b is 1. So yeah, it passes to negative 1 upon 5 and 4 upon 5. Oh, no, wait. That's negative 5 over there, so it's negative 1. Then it passes to 1 upon 5 and negative 4 upon 5. Cool. So question number 5, it is definitely wrong because I did it incorrectly. Question number 13. Where is question number 13? Come on. Centroid of the triangle, the equations of the sides are this. Okay, cool. So they gave the answer as 8 by 3 and 8 by 3. And I took the answer as 4 and 4, which is weird. What went wrong? Question number 13, question number 13. Right, so 2x minus 3y plus, oh no, wait. Did I just make Oh yeah, I put something else. Now I understand what went wrong. Instead of putting our modified line into the equation, I put this line 2x minus 3y plus 4 equal to 0 into the equation, which is unacceptable, right? I should have put 2x equal to 3y minus 2, but I didn't. That's why everything went wrong. Okay, so the actual point that you got is it's not the centroid, it's the other midpoint. So the centroid will be 2/3 of this point, which is in fact 8/3, 8/3. So yeah, my process was correct. Just I made a silly mistake, and that's why everything went wrong. So this is not the centroid. It's the midpoint opposite to the origin. So the centroid will be 2/3 of this thing, which is 8/3, 8/3. Okay, now I got it. So that's it. I'll see you guys in the next video. Bye.